which makes this entire thing how much?
60?
60. This is 60 feet, 20 plus 40. Huh? Okay, so can we figure out what these are up here? Yeah, these are different lengths, that's for sure.
Yeah.
Yeah, that's what they indicate anyway.
And send me that back out for confirmation about.
What we do know is that if this length is 60 feet, then this one here has to be 60 feet also. Huh? Okay? So we've covered this side and this side. This is, this plus this has to be 80, doesn't it? Okay. That should be enough to do it, huh? There's 80 on this side. It's broken up into 3 different parts. There's 80. On this side, we have 60 here and 60 here, because we got the 20 plus the 40.
You don't have any measurement. You don't have any additional measurement. I needed one of those small.
You want this? This one you're looking for? So you've got this entire side as being 80. So that's this plus this plus this. Let me put a tick mark on it. Add those 3 things together and you get 80 over here. Okay? These two obviously add to 60, so this one plus this one has to add to 60. Let's call it like that. Let's put double marks on that. Okay? So we do have everything, don't we? We've got it, but we've got it in an added way. Okay, well, let's do this. This much is 80, we know that. That's 80 feet on that side. That's one side of 80 feet. Huh? All right, we don't know this one and this one, but we do know the sum of them. The sum is 60. Okay, likewise, we don't know the small one up here, this one, or this one. They didn't tell us either any of those 3. But we know the sum of them is 80.
80, 60, 60.
And then down here, we've got 40 plus 20 again, which is 60. So we don't know the specifics of these sides, but we do know the sums, and that's all we're looking for. Because we're doing the rain gutters, and the rain gutters have to go around every part of it. Okay, so that gives us 0 here, and 8 and 8 is 16, and 6 and 6 is 12, 16 and 12 is
280.
Oh, so we don't even need to know those measurements.
Sorry?
We don't even know those measurements.
We don't need to know the specific measurements, but we have what we need to get the rain gutters.
Well, yeah, but you're gonna have more rain gutters than you need.
Yeah,
I
yeah.
mean,
I'm sorry?
you're doing 60 by 80, but you're gonna have rain gutters to go around the whole thing, but you're gonna be wasting money because you're gonna order more rain gutters than you need.
No,
I think it
you
seems
need
like
exactly
it.
that much.
Really?
Yeah. Yeah, because you've got to cover every single side. So here you're going to cover that and that. That happens to be 60. Here you're going to cover this, this, and this. That happens to be 80.
But what about the open areas? I mean,
There's no, well, that, you're still going to have to cover these 2.
huh, interesting.
So everything is getting covered by doing the edges.
Wow.
Isn't that interesting?
Yeah,
What's the formula for the rectangle, sir?
Oh, no, that's not a rectangle. It's several rectangles put together.
Huh.
But it just happened in this case that what they're asking you for, you do have the measurements. Strange, for sure.
Wow.
Is it number 25?
25?
Oh.
Interesting.
Alrighty, it says, find the lengths of the 2 missing sides, labeled X and Y, then find the perimeter of the figure. And this is an L-shaped thing. And we do know that this is Y, this is X, this is 300 millimeters. This is 4.5 decameters. This is 250 millimeters. And this is 7.5 decameters. Okay, now the question is this, they've mixed units on us. So what we have to do is decide on one unit or another, it doesn't matter which one, but we have to convert between the two. And everyone remembers their prefix bar, right? Something about donuts? Yeah, we're talking about meters here, so this is kids have donuts until dad calls mom, right? So it is. Okay, so this is deca over here, and milli is over here. Okay? Now we can convert from either one to the other, it doesn't matter. Let's see what my book does, I don't know what it does. It gives you the answer in both. Okay. So let's do millimeters, huh? So we've got 7.5 decameters, and we want to convert that to some number of millimeters. We do it by shifting the decimal point around on the prefix. We're starting here at decameters, we're going 1, 2, 3, 4. Go over the millimeters, 4 to the right, huh? So 1, 2, 3, 4. Okay, that's 75000. 7,500 millimeters. That's a lot. Let's make sure the prefix is correct here. Sometimes that deci and deci thing I get mixed up, so let me just check it to be sure. Oops, no, sorry, that's the wrong one. This is a different abbreviation. This is DAM. This is DM. Okay, so we have to go from there to there. So we've got 2 over, not 4, but 2 over. 1, 2, so that would be 750 millimeters. So that's how much this is, 750. Same kind of thing up here, that's 300. Let's change the decameters up there, that's 4.5 decimeters. And we want to change it to millimeters. So again, we go 2 to the right, 1 going, that's 450. Okay, now we've got everything in millimeters. Okay, so trying to get Y up there, we know the entire thing is 750. If you take away this much, the 450, you're going to have what's left over, and that should be the Y up there. So 750, take away 450 is 300 millimeters. Likewise over here, X, well this is 300 and the rest is 250, so that gives you a total of 550 millimeters. Okay, so we're in the millimeters now, and then we add them up. And that will look like this. 550, 300, 300, 450, 250, 750, and that's it. Some of them are easy to add, 10, 15, 20, and so forth, 9, 11, 14, 15, 18, 21, and 6 is 2, 21, and 5 is 26. 2,600 millimeters. Is that there? No.
Or 26 decimals.
Mm-hmm.
2016.
Okay, any others? Yes.
45.
45. Now this is a composite figure, so it's made up of 2, and you'll need to use that to get the right answer quickly anyway. Usually they don't give you enough dimensions to do it any other way. You have to add, subtract composites. Okay, so you've got a rectangular area, large room, except for a fireplace, which has probably tiles or something like that. And all of this wants to be carpeted, but that does not. So they tell you a few dimensions here. This is 10 feet. This one here is 8 feet. That's from here to here. The height, they do tell you. That height right there is 1.5 feet. This is 22 feet, and this is 18 feet.
Well, why is the height there?
That height right there?
Yeah.
Yeah, that's perpendicular. Because without it, you can't get that area.
No, but also it's like, it doesn't need to be there.
It doesn't what?
It does not need to be there.
Yes, it does. Because you need to know the area of that thing.
Yeah, they want carpet and
Oh,
tile.
you're gonna carpet that little area too?
This is the area you're gonna carpet over here, but you're not gonna carpet that.
Okay.
So the way we're gonna do it is subtract that area from this area. Okay? So
Yeah.
let's do the area first of the rectangle. The rectangle is this entire thing, right? It includes that fireplace part. That the rectangle includes the whole thing. Okay, how much is it gonna be? The area of a rectangle is length times width, right? The length is the larger one, so here's the L, and the width is the smaller one, that's the 18. So it's 22 times 18. We'll figure that out in a minute. Now, the area of that shape is not a rectangle, that shape is a trapezoid, huh? So it takes a different formula to get the area of the trapezoid. So the trapezoid area is 1/2 times the sum of the bases, they call it A and B. A and B, times the height. Okay, let's put those numbers in so we can calculate them. B is usually the longer base, 10, and A is the shorter base, 8.
That's where I got wrong.
And here's where you need the height, 1.5. So you can't get the area of the trapezoid without that. Okay, so let's get out our calculator. You just can't wait to go here. This is 396. Now remember, areas in square, whatever, in this case feet, no? Square feet. Okay, now here you've got 10 plus 8, which is 18, times 1.5. But 1/2 of that, you can simply divide the 18 by 2 to get 9 times 1.5. Or you can put the whole thing on your calculator, it doesn't matter. So this is 13.5, and that's again in square feet, which is right like that. Okay, so now we have to subtract the trapezoid from the rectangle to get the area that's going to be actually carpeted.
Got it.
So it's 396 minus 13.5.
Okay.
382.5 square feet. Probably the people who comes to install the carpeting won't even pay any attention to that. They'll just go with the 396 and just leave you some leftover. That's what they do, because they say, well, you know, you're gonna have to patch it sometime. So they just leave the whole thing. But that's practice using formulas. Any others? Okay, let's go on to the next section, which is on circles. Now, of course, there's some different definitions. Of all the shapes that we've talked about in geometry so far, there's only one you can find in nature, and that's the circle. Now, it's also true that to talk about the perimeter and the area of a circle, there's only one way to do it, and that is to use an irrational number. You know, there's things that you get killed for if you tell other people. So, and you see, is that an accident? The fact that a circle is a natural shape, And an irrational number has to work, in calculations for a circle. Not really. That happens an awful lot. When you go into various forms of math, for example, you go to Algebra 2, some of you will have to take that. You're going to look at numbers that, again, are irrational numbers. And you say, well, what use is it to talk about this number called E? They actually call it E. Yeah, the little letter E. Irrational numbers are often given strange letters, that's all. But it is a very definite number. It's just that it keeps on going forever. You say, what use is it? Well, it turns out your hair grows according to that number, E. It turns out that all sorts of things change in nature according to the number E. And you say, what are these things, and why are they irrational anyway? Can't they be nice little fractions or something? No, not really.
I've heard that they refer to pi often as being part of infinity, because it can just keep going out and out and out, and the number never ends. So it's kind of connected to infinity.
Well, it is. In the decimal system, it is. See, the problem is really with our number system. Our number system is easy to calculate with, but you're going to have a lot of numbers, especially the natural numbers, the ones in nature. They don't do well in the decimal system. They have infinite numbers of digits. It's not a big deal, because you chop them off at some point, that's all. You say, that's all I have time for, so I'll chop it off the hundredths position, the thousandths position, or whatever. So you use whatever you need. But it's strange that in our number system, nature is almost not allowed.
Well, it is a linear system, in a sense.
Yeah,
Doesn't make math
And
unnatural.
that doesn't kind of match with nature a lot of times.
it does not, that's true. Okay, let's talk about the circle. Some definitions first. Yes, everyone knows what a circle is, but we have to talk about the mathematics of it. It starts with the idea of a point, and remember that idea is not well defined in geometry. Basically, a point is something that has no existence. But if you want to talk about a circle, you define it in terms of a point, and it's kind of an interesting definition. Circle is a set of points the same distance from one point.
What page are we on?
Oh, roughly page 494. So we'll call this the center of the circle. That one point is the center. Here's the center of this circle. I'm, of course, approximating. And the distance that these other points are from that one point is called the radius. So you can draw a ray that comes out from that center and goes over to the circle. And you can even put a little arrow on it, usually they do. Label it R. You might call C the center. Most of the time they don't even label the center, it's obvious. But this is A, or the radius of the circle. And every single point on the circle is that same distance, so that's what the definition means. It's a set of points that are the same distance from the center. There's another definition that is used sometimes, and that is if you draw a line that touches the circle in two places and goes through the center, like that, you get something called a diameter. So radius there, diameter here. The relationship between the two is very simple. You can look at it and see what it is. This half of the diameter has got to be a radius, and so does that half of the diameter. So therefore, the diameter actually is 2 times the radius. Or another way of putting it is, if you want to think of the radius, it's the diameter divided by 2. It's just 1/2 of the diameter. Okay, now here's stuff that gets to be kind of strange. It's almost mystical. Circumference. Now circumference is the word that's used with circles that means perimeter. It's just the distance around the edge, that's all. But for a circle, it's called circumference. So you're taking a tape measure, you're attaching it at one side and wrapping it all the way around, and you want to know what is that distance. Well, the distance is kind of a strange thing. The formula for it looks like this. C, which is circumference, is equal to either pi times d or 2 times pi times r. Now, you say, well, why do they give you these two formulas? Because sometimes you have the radius of a circle, sometimes they're giving you the diameter of a circle, so you should be able to use either one. Since the diameter is 2 times the radius, then of course these two are really the same formula. It's not a big deal. But there's that pi. There's that Greek letter pi, which is an irrational number. Now this is true for all circles, this formula, which means the following thing. It means if I divide both sides by d here, c over d is equal to pi. That irrational number that keeps on going forever, huh? Most of you have a pi button on your calculator, so it's not hard to work with. You can just push the pi button. But this has nothing to do with the particular circle you're talking about. This is true for all circles. All right, what does that mean? Well, if you look at the edge of this, you've got a circle. This is a circular object here, huh? And let's say you take a tape measure, wrap it around, you get the C, and then you are able to maybe use a ruler to get the diameter and write, the circumference on the top, diameter on the bottom, you'll get pi. If you go outside, when Homer's doing his astronomy stuff, they put these telescopes out there that have filters on them, so you can look at the sun under certain conditions. It's kind of interesting because the sun gets a lot of sunspots every once in a while. So you look up there, it's a circle. Yeah, if you could go out there and measure, the circumference of the sun and divide by the diameter, you get the same number. If you take a can of beans and measure the circumference, divide by the diameter, you get the same number. That number never changes. No matter what size the circle is, that ratio of C to D is 3.14. Let's write it out. We say it's approximately 3.14. If you wanted to actually put it in, I think your book writes it for you there on page 495. You can put in a few more digits in it. Your calculator will take it out to 10 digits. 1, 4, 1, 5, 9. Let's see, what are the rest of them? I never use the rest of them. 2, 6, 5, 3, 5. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's even got 11 place values in it. That's more than your calculator has. And so how do we deal with this? Well, if you push the button on your calculator for pi when you're using it in a problem, to solve a problem, it will give you up to there. Now, probably you will change that to a 4, because it probably is set to round. And if it's rounding, then the next one's 5 or greater, we change that to a 4. But that's what you get on your calculator, huh? Well, what kind of accuracy is that? Well, tenths, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions. Okay, we're on the billionth position. So if you're talking about inches or centimeters or something like that, you're talking about a billionth of an inch. All right, now nobody needs more accuracy than that, I mean, the stuff we make on this planet, the accuracy is, except the stuff that NASA gets. They better have more accuracy. All right, so what we do is chop it off. So if we're going to use pi in the calculation, most people will stop right there. That's the hundredths position. Why? Because the next number is 1, and that's in the thousandths position. So by chopping it off there, you're missing it, but you're only missing it by less than 1,000th. And that's usually pretty good for most calculations, Unfortunately, they do another thing with pi, and I really suggest you don't use it, but They say it's approximately the fraction 22/7. Well, it can't be 22/7 because pi is irrational. Irrational simply means it can't be written as a ratio, so it can't be written in a fraction. That can't be done, in other words, that's wrong. Equal sign would be wrong, but it's approximate. Well, let's see how approximate that is. Let's see how accurate 22/7 is. You just simply punch in 22, divide 7.
So you get 3.14.
And what you get for 22/7 is, again, we're going to approximate it, 3.1428574143, and it keeps on going. All right, so to the hundredths position, it's the same as 3.14. But, you know, there it starts being very different. 159, no, 285. So out here in the thousandths position, it's more than a thousandth away from it. You know, so if you need a lot of accuracy, this is not the way to go. Just simply use the original pi and take it out to however far you want to go to get the accuracy you need. So that's the way we deal with pi. Having that in mind, let's calculate a couple circumferences. Your book says, okay, you've got a circle and its diameter is equal to 8 meters. Okay, you want to know the circumference of the circle. Well, since you've got a diameter, this is the one to choose. Choose the formula that has diameter in it. So the circumference is going to be 8 pi. Now, that's an exact answer, because pi, that symbol, that Greek letter pi, is considered to be the infinite number. Okay, so this is exactly right. But very often they'll say to you, now approximate it to the thousandth or something like that. And they say using 3.14, give an approximate answer. You should always do the squiggly equal signs if you're going to use 3.14. All right, so it's going to be 8 times 3.14, and multiplying that out, you get 25.1. So 8 meters across, all the way around, more than 25 meters. That's the simple use of pi. If you do have the radius instead of the circumference, then it's better to use the other formula. So suppose you had something like this. They give you a radius, and in this case, they're looking for 5.1 feet. Well, at that point, the formula to use is 2 pi r, because that's got the radius in it. And you can just plug that number into it. Huh? Okay, so it would be 2 times pi times the radius, which is 5.1 feet, which is 10.2 times pi. And then they say, okay, now give me an approximate answer. So you do 10.2 times 3.14, and you put it on the calculator, and you get an approximation. And this comes out to be approximately 32.03. Rounding to the hundredths position, it would be 0.03. There is some justification for rounding it to the hundredths position. And the reason is, you're rounding pi to the hundredths. This number over here is rounded to the 10th, but it's not actually rounded. They gave us 5.1, so that is actually an accurate number. But we're rounding pi to the hundredths. Therefore, the answer we get can't be more accurate than that, because if this is off in the thousandths position, this is going to be off in the thousandth. So you round to whatever the position is that is your least accurate, so to speak. So 3.14. Okay, let's talk about area. We got circumference, and now we go to area. A very interesting little pictures in your book, and I hope you can look on if you don't have one. It's on page 496. Okay, what they did is they took one circle, which is made up of a top half and a bottom half, pink and blue, and they split it into several pieces of pie, so to speak. Then they took just the top half and opened it up so that the blue pieces of pie are perfectly vertical, all lined up but perfectly vertical. And then they took the bottom half, again, take the pink pieces of pie and insert them so that you've got this kind of up and down blue, pink, blue, pink, blue, pink all the way across. Okay, now what they can do is estimate the length of the blue pieces. We know that the circumference is equal to 2 pi r. Now that's for a circle, that's for the entire circle. But what we're doing with the blue is simply taking half the circle. So we want 1/2 the circumference. Okay, the 2's cancel, and 1/2 the circumference is pi r. And when they line these things up, what they do by interjecting the pinks and the blues like that is they give you something that looks very much like a parallelogram. Now, admittedly, it's sort of got a bumpy top on it, you know. So what you have to really think of is, suppose I cut my pieces of pie smaller and smaller and smaller. Maybe I had, you know, dozens of pieces on the top, dozens on the bottom. Well, the bumps would smooth out, okay? And it would be more and more like a parallelogram. And what's the top side of the parallelogram, which we call the base of the parallelogram? Well, it would be half the circle, which means it would be that right there. So you've got this little bumpy thing going on. And this much right here is going to be pi r. Now this much right here is very close to the radius, because that's one. If you look at the piece of pie and you draw the radius in it, that's going to be the height of the parallelogram. So that's going to be r. So to figure out what the area of that is would be a matter of simply multiplying pi r by r, length times width, and that gives you pi r squared. Now, that's a very simple way of looking at it. There are forms of math that can actually get this from scratch, but unfortunately they're pretty advanced. That's what's called calculus. And calculus is a beautiful form of math, but way beyond anything we want to do right now. So here we've got the area of the circle being pi r squared. This is just to motivate the idea, that's all. It's not a proof or anything like that. And for our use, it's fine. Let's go back here and take that circle which had an 8-meter diameter. This was the diameter. Okay. If the diameter is equal to 8 meters, then the radius is going to be 1/2 of that. You simply divide by 2, so you get 4 meters for the radius. And then according to this, the area of that circle is going to be pi times r squared, which is 4 squared. So it'll be a 16 pi. And then you have to put in 3.14 again. And that would give you the following. $50.24. Now, this is going to have units, and like any other area units, they're going to be square units, and we started off with meters, so this would be square meters. That would be the area of that circle which had a diameter of 8 meters, 50 square meters. Let's do another one of these composite problems so you can see how they work with circles. What we're going to do is take something which initially looks sort of like a rectangle, but then take a bite out of it, so to speak, with a circle. Like that. Might be the kind of thing that you'd work in a machine shop and it's a part of some sort of device or something, who knows. And what they show you is that this is 10 centimeters, this is 6, And that's all they tell you. And they want, of course, the area that you see there. Now, this is a half of a circle. Half of a circle is often called a semicircle. So, it's very much like the problem with the carpeting and the fireplace. What you can do here is find the entire area of the rectangle. Just think of dropping this line down here. Now you've got a rectangle. That's easy to get. The area of the rectangle is going to be 6 times 10, which is 60 square centimeters. Okay, now what we want to do is subtract the area of a semicircle. Well, the area of a circle is pi r squared. And what's the r? That's the question. Well, they don't give it to us, but we could actually figure out what it is. Because remember, these points have to be the same distance away from the center. And anything that goes from the center to the edge of the circle is a radius. So that's a radius right there, that's r. If you go back over here, well, the whole thing is 6 centimeters, so this r has got to be half of that, which is 3 centimeters. All right, now we can go into the formula for the area of the circle, pi r squared. It's going to be pi times 3 squared. And that's the area of the whole circle, so that's going to be 9 pi. We actually want half of a circle, so we want half of that circular area. So it'll be 1/2 of 9 pi, which is 4.5 pi. Okay, now we can figure out the area of this piece in here. Okay, let's put that on the calculator, see how much it is. 4.5 times pi. Get 14.13, and this again would be centimeters. Okay, now we want to subtract that from the 60 up there. The area of the rectangle minus the area of, well, 1/2 the area of the circle is 60 minus 14.13. Which is 45.87 centimeters. So it's a matter of working with the formulas of area, circumference, and stuff like that. Okay, we're going to stop here today. Tomorrow we'll have our lab as usual. This is section 8.4.